All right, so now we're at topic 2 of Unit 5, and this is a required video for everybody in the class. So whether you're in Algebra 2 or you're in Algebra 1, I definitely want you to take notes on this video. And you might want to pull out the notes that we did in class because we're going to complete or bring some closure to those loose ends that we had at the end of our time together. So take a look at my summary that I have here. Which should be reflective of what we did in class. All right, so first we have y equals ax squared, then we have y equals x squared plus k, and then we have y equals x minus h squared. So I have kind of in a purple color the basic part of our equation, because if you remember, the most basic equation that we have is y equals x squared. And that has the general shape of looking, oops, went a little too low, of looking like a parabola, which is a U-shaped graph. So y equals x squared is a U-shaped graph. What we wanted to know during class today is what happens if we adjust this graph by, say, multiplying by a number or adding a number. And the first thing that we noticed is that when we multiply by a number, which here we called it a, it adjusts the steepness of the graph. So for instance, if it was something like y equals 10x squared, our graph would get really narrow because it'd be growing really quickly. On the other hand, if I had something like y equals 1/10 x squared, it would grow really slowly, which would make it look wide and flat, like somebody stepped on it. And again, the reason is because of this letter A, which adjusts the steepness of the graph. If it is negative, if it's positive, it has a U shape. If it's negative, it flips upside down. So positive A is U-shaped, negative A is what we call a vertical flip. It's an upside down U. So we did bring some closure to that in class. Then we were talking about the difference between K and H. And if you notice, the real difference here is that K is a number we add outside of x squared, of our function x squared, and h, which there's a reason that I say minus h and not plus h, and we'll talk about that in a minute, is inside. We actually have to put parentheses up to show that it's inside the square. So this number is an outside addition, and this one is an inside addition or subtraction. And the question is, how does that adjust the graph? And in short, we'll define it this way. You should be able to see it more clearly with using your calculator, but I'll just summarize it by saying K gives us a vertical shift. And that means if I had something like y equals x squared plus 2, I would take my nice little U-shaped graph that usually is right down here on the origin, and I would move it up 1, 2, same shape, but it would move up 2. On the other hand, if I had y equals x squared minus 2, I would take my parabola and I'd adjust it down 1, 2. Same shape, but I move it down 2 units. So the letter K, or the number that we would add on the outside, adjusts our parabola by moving it up or down. And so then it probably won't, actually I'll write that, up, down. Up is when it's positive, down is when it's negative. So it won't surprise you to find out that this last one, the H, is what we call a horizontal shift, and it moves our graph left and right. But the one thing that's a little bit tricky here is that it goes kind of the opposite of how you'd expect. For instance, let's say we said x plus 2, see how I'm putting it on the inside this time, not on the outside, squared. I would take, I'm going to draw a line here so we don't get confused. You'll have a little bit more room in your notes. We would take our typical graph of a parabola, and instead of having it oriented right here at the origin, we would move it horizontally, but positive 2, x plus 2, moves it left. So that's a little bit weird because you'd think that you'd be moving it right because it's positive, but it's not. It's the opposite of what you think. If it's positive, it moves the graph left. It keeps the same general shape, but instead of starting at 0, it starts at -2. So this would move left 2. Similarly, if we have x minus 2 squared, that will also take our original parabola and move it, but this time it will move it to the right. So a negative, same shape, but to the right, right 2. A negative number inside adjusts it to the right. And what I just tell students often is, remember with the horizontal shift, it's just the opposite of what you would think. With the vertical shift, it's pretty straightforward, up and down, just the way you would think it would be. But with the horizontal left and right shift, it's the opposite of what you think. Positive moves left, negative moves right. Okay, that summarizes what we talked about in class. I am going to, before we finish here, I'm going to write this as one big equation. Because what we need to remember when we deal with parabolas is that there are it's not just the y equals x squared. That's not the only quadratic out there. You can move them all over the place. You can move it up or down, left or right, or you can move it up and right, or up and left. So for an example, let's say I had this equation here. What this would tell me is that this first number out here is going to make this grow fast, twice as fast as normal. So instead of being a typical parabola, that was kind of a funny parabola. Let's do some actual points. So 0, 0, 1, 1, -1, 1, 2, and 4. -2 and 4. So this is our typical parabola. Sorry, those don't go exactly through the points. We'll pretend that they do. If it's growing twice as fast, then instead of going to 1, 1, it'll go to 1, 2. And instead of going to 2, 4, it'll go to 2, 8. So every point gets doubled. So if you look, when we do that, that's what makes this parabola look more narrow. Sorry, again, that looks... There we go. So this 2 out front is going to make our parabola more narrow. It grows twice as fast. This next number, the -4, is going to cause the graph to move right 4. Remember, it's the opposite of what we think. The negative, you'd think it'd go left, but it doesn't. It moves it right 4. And then this last one, the k, moves it up 3. So what does that actually mean on a graph? Just roughly, because we have graphing calculators that can graph nice and specific graphs, we want to just be able to roughly estimate what this graph will look like. So for instance, here I know that instead of starting at 0, 0, it's going to move 1, 2, 3, 4 to the right, and it's going to move 1, 2, 3 up 3. So right 4, up 3, and then it's going to be extra steep. So instead of being more narrow, it's extra steep. So this is roughly what our parabola will look like. A narrow U moved over here. It actually never hits the x-axis in this case because we moved it over and up. All right, I will pause there. We're going to pick up with this equation in a moment, but so keep it in your mind, but we'll move on to the second part of our topic 2 notes, which will be how does this apply to solving equations. We just went back to the idea of graphing. So the question is, where does solving quadratic equations fit into what we just looked at?